Dear student, today I am here to discuss with you the concept of rotational symmetry. Now what is this rotational symmetry? As you are hearing the term rotational means an object which can be rotated for about 360 degree, or you say it as a complete turn. So when you see all around yourself, there are many objects, or you can say infinite object which is having the power of rotational symmetry. It means every object has a power of rotational symmetry. What means to say that every object, when it is rotated for about 360 degree, it will come at least once at its original place. But there will be many objects which comes more than one time at its original place when you rotate it for 360 degree. So the number of time an object comes to its original place in a rotation of 360 degree is called as order of rotational symmetry. So our next exercise is based on that order of rotational symmetry, that by seeing the object you need to decide that particular object has how many order of rotational symmetry. Although in rotation the shape and size of the object do not change, but rotation always occurs about a fixed point. That fixed point is called as center of rotation. Like if you want to rotate this particular marker, so I have to fix it from the center so that I may rotate this object and it comes back to its original place. When you see that this object is rotated for about 360 degree, it is coming once at its original place. But there are many objects that when you rotate for 360 degree, so in a complete rotation of 360 degree, it may come more than once at its original place. So the object which come more than once at its original place, that only gives the order of rotational symmetry. So our second exercise is based on the same concept. Although the rotation could be done clockwise direction or could be anti-clockwise direction, that is up to you. So you may do in the clockwise direction or you may do in anti-clockwise direction. But you cannot do once clockwise, one anti-clockwise. This is not possible. So unless and until an order is complete means if a turn you are doing, that turn should be completed for 360 degree. It means when a circle is completed. So when a circle is completed, that's an order of 360 degree, angle of 360 degree, that is called full turn. Now when it is for 180 degree, that is called half turn, and when you turn for a quarter, that becomes 90 degree. So in this 14.2, in the first and second question, I need to find it out for different object what is being given there, what is the order of rotational symmetry. Although I have given you the homework which is there along with given in the syllabus also, that in exercise 14.2 in first question B, D and F part is homework, and in the second question B, D, F and H part is the homework. Other than that, whatever left, that I am telling you as a part of classwork. So in the first question you need to find it out, whatever the objects are being given there, that how many objects are having more than one order of rotational symmetry. That only you need to find it out. So I have taken a circle. As you know that circle has infinite order of rotational symmetry if any marking is not being done on the circle. So here you will see that if the center of circle is fixed here. So if you mark your circle, like name it as A, B, C, D. So when you are going to do the rotation of this particular circle, so if you rotate clockwise, so if A starts from here and until and unless A comes here back, that won't be said as its order is complete. So when you rotate it for 90 degree, A will shift to here. When you rotate for again 90, A will shift here. Again 90, A will shift here. Again 90, A will shift here. It means till the A comes back to its original place, all the time circle remain at its original place only. So it means that this particular figure is having more than one order of rotational symmetry. Exactly we can say that 4 order of rotational symmetry as it comes 4 times to its original place. So it means that this figure is having 4 order of rotational symmetry. Now when you come for question number 1C part, here also the center of this object is fixed. Now when you rotate this, if you take as this part as A and this part as B, so unless and until this A, if you rotate clockwise, come back to its original place, it won't say as its order is complete. So when you rotate it for 180 degree, A will come here and this turn will turn this side. When you rotate the object, it's something like the cap of this which is there or tilted towards the right. So when you rotate it, it will come towards the down and then to the left side. It means it won't remain at its original place. So its order is not complete now, and it's not coming back to its original place. Again, when you rotate it for 180 degree, so again then only it will come back to its original place. So it is having only one order of rotational symmetry. It is not having more than one. Although in question it asks for that how many objects is having more than one. So this is one object which is having only one order of rotational symmetry. Now when you come for this part, again when you label it so that you may find it out that where is the starting and ending point. If you take A as a fixed point, so A will come here in one order, circle remain at its place. A will come here, again it's one order, circle remain at its place. A will come here in one order, again circle remain at its place. It means in a complete turn, circle remain at its place 3 times. So order of this figure or object could be 3. So first figure is having 4 order of rotational symmetry. Third figure is having 3 order of rotational symmetry. But the middle figure is having only 1 order of rotational symmetry. So according to question it was asked that which object is having more than one could be among this one and this one, as this object is having only 1 order of rotational symmetry. Now coming to the second question. Second question says that you have to find it out how many order of rotational symmetry is present in the figure for A, C, E and G part. On the fixed point is already given there. At the you can say that the center of rotation of that particular object is given there. Now we need to find it out. What is the order of rotational symmetry of these particular objects? So if you say for this, if you say this as a starting point and this as the second point, so when you rotate it for 180 degrees, so this will rotate in this part and it will come back to its original place only. But our order is not complete. Although it is coming back to its original place, but its order is not complete. It means one order is already having before completing its complete turn. Again when you rotate it for 180 degree, it will again come back to its original place, and now it is the second time it is coming back to its original place. So in a complete turn of 360 degree, it is coming 2 times at its original place. It has 2 order of rotational symmetry. Clear? So when you have any object, you have to assume it, or you can draw with the help of cardboard and some paper. Just make it in this form and just rotate about a fixed point. You will see that as it is one towards right and one towards left, one flag type object is there. So when you rotate it for 180, it will be at its original place. Again you rotate it for 180, it will again be its original place. It means in a complete turn of 360 degree, it come back to its original place 2 times. It means therefore this particular figure is having 2 order of rotational symmetry. Now when you go for this triangle, if you see that triangle, sometimes it looks like an equilateral triangle. So when you rotate, if you take it as fixed point A, B and C. So when you rotate about this fixed point, A goes to this side, B this side, C this side. So this is one time it is coming back to its original place. When A becomes here, then it will again remain its original place. When A becomes here, it will again remain at its original place. It means in a complete turn of 360 degree, it is coming 3 times at its original place. So it is having 3 order of rotational symmetry. Now when you go for this plus sign, if you take it as A, B, C, D, unless and until A come back to its original place, your rotation won't be complete. So once A is shifted here, this will shift here, this will shift here, this will shift here, it remain at its original place. Now when A is here, it will again remain. A is here, it will again remain. Now A came here, it will again remain. It means in a complete turn of 360 degree, it came 4 times at its original place. So its order of rotational symmetry become 4. It is very easy to find it out, order of rotational symmetry, by seeing the figure also. That if you see a polygonal type figure where the sides are equal, you will see that it will always have more than one order of rotational symmetry. Okay, now let's see the last part of this. Here you will see that, please excuse me for the last figure, it's not accurate which is given according to the book. Here it's a star shape given there. Here also I have labeled A, B, C, D, E, F. Now when A from here to here shifted, it will remain at its original place. Now A from here to here shifted, you will see that it will again remain at its original place. Same goes for here, 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 here. It means when A is shifted for 6 times in an order to complete a rotational symmetry, the figure remain at its original place for 6 times. It means that this particular figure is having 6 order of rotational symmetry. So here you have seen that according to the objects given there, we try to find it out that in a complete rotation of 360 degree, the number of time an object comes to its original place gives the order of rotational symmetry, where first figure gives 2 order of rotational symmetry, the triangle has given 3 order, the plus sign has given 4, and now the star one, that the last one, has given 6 order of rotational symmetry. So this is all about for the second exercise. In the third exercise, we'll try to find it out the same thing, but might be for different quadrilateral or for different other shapes. Till then, stay safe, stay happy. Thank you and Jai Hind.